All right, so let's start today off. We're going to talk about graphing today, but let's do a review of what we learned last time. So would we find the x-intercept here, the y-intercept, the vertical asymptote, and the horizontal asymptote? Most of these we can actually figure out without factoring that, but we would need to factor that to get the x-intercept. So let's actually I'm going to rewrite it into factored form, but I'm going to ask Emma to help explain her thought process. Emma, if I'm factoring that, what am I thinking in my brain to help me factor that trinomial?
You are trying to multiply to get -6 and add to 1.
Great. And what numbers would multiply to -6 and add to 1?
2 and 3.
Great. Now one of those is going to be negative. Which one?
I think it's the 3.
So if the 3 was negative, it would multiply to -6, but then it would add to -1. So we're going to make
okay. So
2 negative, so then it adds to a +1. All right, cool. So now, with that in mind, I can write f of x as x plus 1, and then x minus 2, x minus 2 and x plus 3. All right, now, I hope you have your notes nearby, but what I want to do is go through how did we get the x-intercepts last time, how did we get the y-intercept, how did we get the vertical asymptotes, how did we get the horizontal asymptote. And sometimes it'll be easier to work with the non-factored version of f of x, and sometimes it'll be easier to work with the factored version. So Mindy, I want you to start us off. Do you remember how we got the x-intercepts?
You make the numerator equal 0.
Awesome. And then if I did that and solved, what would x equal?
-1.
Awesome. Thank you, Mindy. All right. Braden, do you remember how we got the y-intercept?
Give me a moment. I'm flipping through my notes if my hand will listen to me.
That is just fine because I'm actually going to ask Caleb.
Oh, you plug 0 into the variables.
Great. And then I'm going to give Caleb, you're going to get a head start. I want you to do the vertical asymptotes, okay? And then Skylar, can you explain the horizontal asymptotes? If you need to look at your notes, I'm giving you a little bit of a heads up. Okay, so thank you. So plug in 0. So I'm going to put a little note. Braden, if I do plug in 0, what does that make? What am I left with? Let's plug it in on this one.
I haven't solved it yet, so I need a moment if that's good.
That's good. It's actually, if I go to this one, anywhere I see an x, I'm just going to cross it out because it turns into 0. So I can, if I just cover up the x's, you can see there's a 1 in the numerator and a -6 in the bottom. I'll move that negative up. So your y-intercept is -1/6. Now, if you plug the 0 into the x's when it was factored, you'd still get the same answer. It just takes a little more work. Awesome. Caleb, help me out with the vertical asymptotes. How do we get those?
No, first. Is it just the bottom or all of them?
Just the bottom. So what would make the bottom become 0?
The excluded values would be 2 and -3.
Perfect.
And it would set that equal to 0.
Or set it equal to x. Like, oh yeah, okay. I think we're saying the same thing, so we're good. Nice, thanks, Caleb. Skylar, can you tell us about the horizontal asymptotes?
Would the horizontal asymptote be 0?
It would be 0. Good job. How'd you get that?
I want to say you set it equal to 0, but I think that's wrong, so I don't know.
Gotcha. Let me pull up the notes from last time on this because the horizontal asymptote is a trickier one. So here's the notes on horizontal asymptote. So the way we find that is we compare the degree, which was the highest exponent. So when I looked at f of x, I looked at the degree of the numerator, which was m, and the degree of the denominator, which was n. And what I did was I compared them to see Is m smaller than n? Is it the same? Is it bigger? And if m is less than n, we get y equals 0 as a horizontal asymptote. If m and n are the same, then we make the ratio of their leading coefficients. And if m is bigger than n, then it means there's no horizontal asymptote. So on this one that we saw, Skylar, what's the degree of our numerator and what's the degree of our denominator?
The degree of our numerator, wouldn't it be 1?
Yep,
And then would it be 2?
yep. And so since 1 is less than 2, that's why we got y equals 0.
Okay.
Awesome. Hey, good job, guys. So now let's actually, what we're going to do today is we're going to talk about how to graph that. What is our graph going to look like if we have an x-intercept at -1 and the y-intercept at -1, 6 and a vertical asymptote? Did we say it was 2 and -3?
Yes.
Okay, cool. Thank you.
Oh, wait, no, it's 3 and -2, isn't it?
So when we factored it, it was 3 and -2. But then I need to look at the opposites of those. That's going to be the excluded values, which turn into the vertical asymptotes.
Okay.
Awesome. And then we got y equals 0. Okay, so if I put all these together, guys, let me show you what the graph is going to look like. So x-intercept at -1, that just means on the x-axis, we cross that at -1. For the y-intercept to be at 1, 6, I think that's going to be right about here. 1, 6, I think it's like 0.385. Let me hurry and check that. Oh, just kidding. 1, 6 is like 0.16. But still, I'm going to leave that dot there. There, I'll erase it. There we go. It's going to be closer right there. Okay, now the vertical asymptote at 2, 3, and then the horizontal at 0, I'm going to draw with this, okay? So x equals 2 is a horizontal line at 2. X equals -3 is a horizontal line at -3. And then y equals 0 is going to be a horizontal line right here. All right, now think ninja star. Remember our ninja star? It looked like, that's what 1 over x looks like. And that's what it's going to look like on the ends. But on the inside, it's either going to make a U or an S curve. And I don't know if you probably won't be able to tell as much right now, but this is actually setting us up to make an S curve. Because if I were to make a U, I would need another x-intercept to go through. And I only have one right here. So the rules are I have to go from one asymptote to the other. The only way we can do that is with a U or an S curve. And this one, the way it's set up is we're going to go through that x-intercept, through that y-intercept, and make an S curve. Now, a cool trick I'm going to teach you about vertical asymptotes is they go opposite directions. So here at -3, if I'm going up on the right side, that means I'm going to be coming down on the left side. They go opposite directions. Now, over here at x equals 2, on the left side, it's going down, which means it's going to be going up on the right side of it. And notice, this is like our ninja star, but now we put an S curve in the middle of it. And that's what this graph would look like. Now, that graph looks a little scary, but you've learned the key components from last time, so now it's pretty easy to just put them together and graph it. Now, how do you know if you've done it right? What we're going to do is we're going to have a tab open to Desmos, okay? So let's go to Desmos. And we're going to put in that equation. Will you tell me what the equation was? Because I forgot. I think it's like x. Yeah, someone tell me what it is.
So it's x plus 1, like the original one, is that what you're asking?
Yeah, sure.
Okay, yeah, x plus 1 and then x squared plus x minus 6.
Okay, perfect. And here we go. This is what Desmos gave us. You can see x-intercept at -1, a y-intercept at -0.16, that's 1, 6, -1, 6. And then you can see there's a vertical asymptote at 2 and at -3, and then there's a horizontal asymptote at 0. And so guys, you did it. Pretty cool, right? Do you have any questions on that? Yes, no, maybe questions? If you do, so I want you to just talk. If you have a question, just unmute yourself and talk, even if I'm still talking, okay? Because I don't always see the chat. So don't be afraid to ask a question. All right, now what we're going to do is we're going to graph 6 of these today. That's all we're going to do is we're going to graph 6 of these. And some of them I'll do with you, and some you'll do on your own, and some we'll do together, or I'll do by myself. Now, a couple of announcements before we get into that too much. I don't know if your other teachers have gone over this with you, but today is an A day, which means tomorrow, Friday, is a B day. But next week, Monday, is going to be a B day. You're going to have 2 B days in a row. And Tuesday is going to be an A day, which is a distance learning day, and then you're done for that week. Then you get Wednesday, Thursday, Friday off for Thanksgiving. So I just want to make sure you're on the same page. So I'm going to have today with you on a Zoom call, but then on Tuesday next week, we're going to have a lesson, but it won't be a Zoom call because we don't do Zoom calls on distance learning days. It'll just be a day you go on and watch the video and do it on your own. Do you have any questions on that? They ended up switching it because they didn't want to have 2 B days, B distance learning in a row, so they just switched the days. All right, so today we're going to learn how to graph them. Next week on Tuesday, I'm going to go over how to write the equations, and then you're going to take your first quiz. Then when we come back, we're going to review for a day and then test. So we're basically ready for our test after Tuesday's lesson. So please make sure you're doing the practices and reaching out if you have questions. All right, so let's start with this one. This is actually one that we broke down and found the components for last time, but now we're going to go and find the, now we're going to go and actually graph it. So we already did this one, so I'm going to kind of go through this one quickly since you've seen it before. But when I'm looking at the x-intercept, I set the numerator equal to 0. Now, does 3 equal 0? Does that make any sense? Can you solve that? No. And if you get something that is a false statement like that, it means there are no x-intercepts. And that's okay. Sometimes there'll be no x-intercepts, sometimes there'll be no y-intercepts, and that's fine. Now to get the y-intercept, I'm going to plug in 0. And if I plug in a 0 right there, I get 3 over -3, which is -1. Now the vertical asymptote is what would make the denominator become 0, which is 3. So at the line x equals 3, I'm going to have a vertical asymptote. All right, and then as far as the horizontal asymptote, we're going to compare the degrees, just like what we did before. Now, where you have to be careful here is the degree of the numerator. How many x's are in the numerator? I could rewrite this as 3x to the 0 because there's no x's. And in the bottom, there's 1x. So the degree of your numerator is 0. If there's just a number, it's 0. And the degree of your denominator is 1. So since we have 0 is less than 1, what this means is that we're going to have the horizontal line y equals 0. So I am going to graph the horizontal line like that. All right, now the general shape we're going to make here is a ninja star. When we're graphing these, we've got to figure out whether the different, we call these branches, whether the branches are going to be above the x-axis or above the horizontal asymptote or below. And same on the right side, is it above or is it below? And if you don't know, you can always just plug in a point. For example, I could plug 1 in and I could say, is that a positive or a negative value? And it's going to give me a negative value. For example, if I did 3 over 1 minus 2, right? So let's plug in 1. Oh, I need a different pen than that, sorry. So I'm going to go to get a new pen, and if I did 3 over 1 minus 2, that's going to give me 3 over -2. So that's -1.5. So that tells me at 1, I'm going to be at -1.5, which is like right around there. Now that's helpful because then I know that all of these points are going to be below the x-axis. The only way we can cross the x-axis is through an x-intercept, and if we don't have x-intercepts, we can't cross it. So now I've plugged in a point and I know that. I actually knew it before because we plugged in 0 and got a negative. So I didn't even need to plug in that point, but it didn't hurt. It just made our graph look better. And remember with the vertical asymptote, if I'm going down on one side, then it means I'm going to be going up on the other side. So it's going to look like that. Looks like our ninja star, right? Now, I'm going to go and graph this. So this is 3 over x minus 3. So I'm going to pull up Desmos and put in y equals 3 over x minus 3. And does that look like what we've got? We've got the point 0, negative 1. And then here we're at 1.5. Vertical asymptote at 3. Horizontal asymptote at 0. And it was below the x-axis on the left, above on the right. Looks pretty good, right? Cool. This is where I'm going to pause. Do you have any questions on that example or any questions like that?
I didn't really get like what you were explaining, like to see if you go down or up. Like, I don't know, I just didn't understand that.
Okay, let me try that again. So, Jade, does it make sense when I'm saying, like, for example, on the right side, it's either got to be up like this or it's got to be down. It's one of those, right?
Yeah.
Does that make sense? All right, so what I was saying is that, well, all of these points to the right of 3, they're all going to be positive or they're all going to be negative. Like, I never cross over because there's no x-intercepts. So a way you can test that is you plug in a point. So for example, I could plug in 4 and say, you know what, let's come back to my original equation and let's plug in 4. I'm going to get 3 over 4 minus 3. Now, what is 3 over 4 minus 3? That's 3 over 1. Now what that tells me is that when we're at 4, our graph, technically it was actually up here at 3. So my graph wasn't super precise, but you know what? It was good enough. You get full points. But the point is, get it? All right, the point is, if I'm at 3, and positive 3, that means all of these are going to be above, which means it's going to be the above one, not the negative one. If I had gotten a negative value, then I would have graphed it below. But since I got a positive, I'm graphing it above. Does that make more sense, Jade?
Yeah, that helps. Thank you.
You're welcome. Now, thanks for asking a question. Plugging in points is always an option, but we're going to learn tricks that you don't even have to really plug in points. Just knowing that the vertical asymptotes go different directions, it's going to help us a lot. All right, so now I'm going to go to this one. And this is going to be the first one where I'm going to give you some Jeopardy music here, and I'm going to have you try to do this on your own. So what I want you to do is I'm going to give you, let's say 30 seconds, okay? And I want you to, let's do a minute, okay? I want you to figure out as much as you can about the x-intercept, the y-intercept, the vertical asymptote, and the sine rate, and then we're going to graph it and check it. So 2 of these songs going now. Let's do that one more time. All right, so I'm going to ask Jade, help me out with the x-intercept. Jaren, can you help me out with the y-intercept? And Maddie, can you help me out with the vertical asymptotes? And then I'm going to leave the horizontal asymptote up to whoever wants to do it, all right? All right, so that was Jade, Jaren, and Maddie, I believe is how I said that. All right, so Jade, how did you get the x-intercept?
So I set the numerator equal to 0, so x plus 1, I set it equal to 0.
And then you solved, and what did you get?
No, I got -1 for the x-intercept.
Perfect. Thank you, Jade. All right, so then let's go to Jaren. How did you get the y-intercept, Jaren?
I don't know.
Okay, so your rule here is let's plug in 0. So if I were to come up here and instead of x, I put a 0, I'm going to get 0 plus 1 over 0 plus 2. So what will that simplify to, Jaren?
1/2.
There you go. That's your y-intercept is 1/2. So 1/2 is right there. Okay, cool, cool, cool. That took us to Maddie. How did you get the vertical asymptote, Maddie?
So what I did is I did x plus 2 cannot equal 0.
Mm-hmm.
And then I minus 2 from the plus 2 and then minus 2 from the 0. So then I got x cannot equal -2. So then I got x equals 2.
Awesome. So thank you, Maddie. We're going to put a vertical asymptote at -2. So I'm going to get out my pen, come to -2. And that's not the straightest of lines, but whatever. Okay, so then someone out there, can you unmute and tell me how we get the horizontal asymptote, please?
So you do the exponents, the highest exponents, and they're equal. They're both 1. They're both equal to each other. So it's a over b. So it's 1 because it's 1 over 1.
Yeah, we have a lot of 1s here. So the leading coefficient of both of those is 1. So when I look at 1 over 1, I just get y is 1. So on this one, our horizontal asymptote is not going to be at 0. It's going to be up here at 1. Awesome. Do you have any questions before we start drawing the branches in on this thing? All right, well now let's start on the right side. Our branches are either going to be below, like that, or above. Now, we've got 2 points that are showing below, and so that's pretty obvious that this is going to look like this. Like that. Now, if we're going down on one side, what does that mean we're doing on the other side? Going up like that. Now, the other reason why we knew it was going up was because if it was below, we would have crossed the x-axis, which would have meant we needed an x-intercept. And there's no x-intercepts over here, so that's another indication that we're going to be above like that. Now, as I'm doing this, my graphs look a little sloppy because I'm writing on a computer, and the points aren't always exactly where they need to be, but a graph like this is worth full points because I've got key components in the right space. And let's check the shape on Desmos. So that was x plus 1 over x plus 2. And does that match what we got here? Let's see, we've got a y-intercept or y horizontal asymptote at y equals 1, vertical asymptote at -2, x-intercept at -1, and a y-intercept at 1/2. Pretty good, guys. Good job. Do you have any questions on that? If not, we're just going to keep going. Like I said, we got 6 of these. So we're going to just slowly tick away at them. All right, now this one is going to require us to do some factoring. What I like to do is I like to write both versions out here because sometimes it's easier to figure out the key components when it's not factored, and then for others it's better when it is factored. So I'm going to go to, who have I not called on yet? Have I called on everyone? Caleb, I don't think I've called on you. Can you explain how you, oh yeah, I think I did, but how would you factor x squared plus 6x plus 8?
You do an x with 8 on the top and 6 on the bottom.
Let me draw that. So I've got an x, and so they are, I usually put the 8 up here to say multiply to 8 and add to 6. Okay, so what 2 numbers multiply to 8 and add to 6?
2 and 4.
Good. But in this case, they're both going to be positive because they multiply to a positive and add to a positive. So I'm just going to write that as x plus 3 over x plus 2 and x plus 4. All right, so guys, it is like super important that you know how to factor these. If you don't know how to factor them, then you're going to be stuck. You won't be able to get your vertical asymptotes very easily. So now what I'm going to do is, again, I'm going to give you another minute here, and I want you to figure out the x-intercept, y-intercept, vertical asymptote, horizontal asymptote. And if you get to that point, then try graphing it. See if you can figure out where the branches are, okay? So we're going to do this yet again, where we are going to be playing our Jeopardy music twice, okay? So try it out. Get going here. One more time. All right, cool. Let's, I'm gonna actually just send this one to, let's go to Mindy. Mindy, tell me as much as you can about this.
So the x-intercept is -3, and the y-intercept is 3 over 8. And then the vertical asymptotes are -4 and -2. And the horizontal asymptote is 0.
Perfect.
And then I got the horizontal asymptote and the vertical asymptotes drawn on my graph. But that's it.
Okay, and that's fine. I only gave you a minute, so great job. Let's go in. I'm going to draw these. So I'm going to start by drawing the vertical asymptote at -4 and 2. And then horizontal at 0. And then I'm going to just start with the x-intercept. Okay. If I just have that x-intercept there, then I really have no idea what's going on with this graph, because I could have, it could be up or down here, it could be up or down there. I'm not sure what's going on. Now, what I do have though is we've already plugged in a point. We plugged in 0. And when we plugged in 0, what did we get? 3.8, which is like 0.375, right? Thank you. That's right about here. Now, that helps us because on the right side, we didn't know if we would graph above or below. Now we know, since we got a positive point here, all of these points are going to be positive as well. So that's what that side looks like. Because since we had a y-intercept at 3/8, we knew all these were positive. Well, now since it's going up right there, that means on the other side, it needs to be going down. Okay, now I'm going to pause right there. On the inside, we can either make a U or an S curve. Now, do you guys remember what would cause the graph to bounce to make a U? What had to happen? Someone unmute yourself, and if you remember, how did we get it to bounce?
If it had a positive exponent because it went on the twice or 4 times, so it bounced back.
Great job. So that Mindy's referring to the multiplicity, which was the exponent of the x-intercept, but it wasn't whether it was positive, not if it was whether it was even or odd.
Oh, that's what I meant. Yeah, I'm sorry.
You're good.
Positive.
So if x
Even.
plus 3 had been squared, it would have an even multiplicity and it would bounce. But it wasn't squared, guys. It was just plain old regular, which means do we bounce or cross? And the answer is we're going to cross. So that's why it's an S curve and not a U. The only time it will bounce is if it has an even multiplicity. And to be honest, we won't see that too much here. But if you take 1050 with me next year, then we'll see all sorts of crazy stuff. All right, so now that that's going up, on this other side, it's going down. It just kind of alternates between ups and downs. And there's your graph. How do you guys feel? Is that something you feel like you got? That you're either you were able to get most of it or you're on track to get it? Well, let's go. Excuse me. Let's go and graph this. So this is x plus 3 over x squared plus 6x plus 8. So go in here. Oh, what the? That did not at all do what I wanted it to do. And I wasn't even looking. Okay, let's see. Will that fix it? Nope. All right, all right. Okay, cool, cool, cool. So let's look at our graph. So we've got a x-intercept at -3, y-intercept at, and I think this was 3/8, right? Which we got there. Was it 3/8? Is that what we said? Where'd you go? Yeah, 3/8. Cool, cool, cool. And then we have a horizontal asymptote at 0, and we knew it was above, S curve below. Looks just like a ninja star, but with an S curve in between the two parts of the star. Okay, awesome. So this is when I'm going to come back to you guys, and I'm going to ask you, how are you feeling? So what I want you to do, hopefully this doesn't crash it. I'm going to stop sharing so I can see everybody. And if you have a camera, you can either just like hold up a 1 through 5 how you're feeling, if you want to put it in the comments, or if you want to just say it. So somehow give me an indication of how you feel, 1 through 5. Awesome. Okay, I've got 2 5s. Everyone else?
4.
I feel like a 4 too.
Okay, cool, cool.
A 4.
Great. If you have questions or you're stuck, please just let me know. We're going to do a few more examples. Oh, wait. Okay, I was like, I thought I was going to like close it. I'm like, I don't want to close this down. Let's do a couple more. But before we do, it's time to get to our first joke of the day. Okay, and it has to do with fractions. Okay, and you're like, fractions can't be funny. Well, you just wait. This one's great. All right. Why did the number 1/5 need to get a massage? Again, why did 1/5 need to get a massage? And the answer is because he's 2/10.
Ha ha ha.
Get it? 2/10.
Yeah, I get it.
Okay, that's your first joke. So if you've hung in here this long, we'll have a little bit of humor. I'll tell you another one at the end. Hopefully it's better than that one. All right, let's go through. We're going to do this one. And this one, again, we need to factor first. And factoring is super important. So I'm going to give you 30 seconds, and I just want you to factor it. So before we do anything else, can you rewrite h of x, but in factored form? Go. All right, Jade, can you explain how you factored that or what you were trying to do?
So I was trying to figure out two numbers that multiplied to -12 and added to -1.
Okay,
And I got 3 and -4.
and you are correct. Good job. 3 times -4 is -12. 3 plus -4 is -1. So right here, I'm going to write that as x plus 3 and then x minus 4. Great job. Were you guys able to factor that on your own? Because that's kind of a big deal. All right.
Yes.
Okay, now from here, we should be able to figure out the x-intercept, the y-intercept, the vertical asymptote, and the horizontal asymptote. So what I'm going to ask is, can I have Maddie, will you do the x-intercept, Emma do the y-intercept, Skylar do the vertical asymptote, and then Braden do the horizontal. So again, that was Maddie, you've got the x, Emma, y, Skylar, vertical, Braden, horizontal. All right, Maddie, let's start with you. X-intercept, what would that be? Maddie, I think you unmuted your camera, but not your mic.
-2.
Awesome, thanks, Maddie.
Mm-hmm.
There's -2, which is our x-intercept. All right, so then y-intercept, I think we would have said Skylar on. No, that was Emma. Emma, what's our y-intercept?
Is it 2 over -12?
You are correct. Now I'm going to reduce that to -1/6, which if I put that in my calculator, that's like -0.16, okay? So that's going to be down like right here. Okay, cool. So Skylar, what about the vertical asymptotes?
Would one be -3 and the other one be +4?
You are correct. -3 and +4. I'm going to draw those right here. So here's -3. And then +4 is going to come over here. All right, and then Braden, how would we figure out the horizontal asymptote on this one?
So the degree in the numerator is less than the degree in the denominator, so it would just be 0.
Perfect. Good explanation. All right, and there we go. Here is our picture. Now, sometimes people get to here and they're like, I don't know what to do from here. How am I going to figure out what's going on? Well, I would say let's start in the middle. You have two options. In the middle, you can make a U or you can make an S curve. So I want you to look at this middle part, and based off the x-intercept and the y-intercept, do you think this is going to be a U or an S curve? So I'm going to give you 10 seconds. Think about that. All right, and then Caleb, what do you think? Is this going to be a U or S curve? What are you thinking?
A U.
All right, so then if I were to make a U, I'd have to go through this point and that point, but then I'd have to come up somewhere over here, right?
Yeah.
But there's no x-intercept there, so are we able to make a U? Unfortunately not. And on this one, we're going to come down and go here, and then we can't go back, so it's, well, then let's go down. So this is going to be an S curve in the middle. And if you thought it was U, that's just fine. I'm going to show you an example in a second where it's really obvious that it's a U. Most of the time, it ends up being an S curve, though, okay? All right, now, if I'm going up on this side of the vertical asymptote at -3, that means the other side we need to be going down, like that. Over here at the vertical asymptote x equals 4, it was going down, so on the other side, we're going to be going up, just like that. Now, You can use Desmos on your quizzes and on your test, and I would highly encourage that. But I would say don't use it until you're done. Okay, you're going to get over dependent on it if you just at the beginning graph it and try to figure it out from the graph. Don't do that. Okay. And as a reason why, did you know at Slick they don't let you use graphing calculators in their math classes like for 1050? You have to do it without them because too many kids were over dependent on them. Okay, so I need to make sure I'm putting this in right. Was it minus x minus 12?
Yeah, that's what it was.
Cool, thank you. So let's check our work. We have an x-intercept at -2, y-intercept at -1,6. Horizontal asymptote at 0, vertical asymptote at -3 and at 4. And sure enough, it was an S-curve in the middle. It was below on the left, above on the right. And that matches what we came up with here pretty darn well, guys. So good job. Do you have any questions on that example?
No.
All right. Well, then we're just going to keep on rolling. I think we've got 2 more, okay? So hang in there. You're almost done. Okay, this next one, we're going to have to factor first right at the beginning. Now, when we go to factor, one of the things that we've got to be careful of is we always look for the GCF, which is greatest common factor. Looking at the numerator, what do you guys see with GCF? Come on, somebody.
Would it be 2x squared?
Well, so the 2 is in both of them. So yeah, take out the 2 and that leaves behind x squared minus 1. And then on the bottom we have x squared minus 4. Now, if you're using notes, don't do what I'm doing because I'm going to erase this in a minute. Now, when I factor the x squared minus 1, that's a difference of squares. And you can factor this 2 ways. One way is you take the square root and I say, all right, the square root of x squared is x. So I'm going to see an x and an x. And the square root of 1 is 1. So I'm going to do a positive 1 and a negative 1. And that's how you'd factor a difference of squares. The other way you could do it is you could say, think of it like x squared plus 0x minus 1. And I would think what multiplies to -1 but adds to 0, and that would be 1 and -1. All right, in the bottom, same idea. I'm going to have a difference of squares here. So I could say, what's the square root of 4? And that would be a 2 and a -2. So that's x plus 2x minus 2. Or I could say, what multiplies to -4 and adds to 0? Again, it's 2 and -2. So more practice with factoring. And I'm going to get 2x plus 1, x minus 1. And then in the bottom, x plus 2, x minus 2. All right, I'm going to erase all of that stuff here that I did for factoring. So I'm just going to rewrite it over there. Now, remember, when you're finding those key components, sometimes it's better to use the non-factored form when it's in standard form. And then it's sometimes better to use a factored form. All right, so let's go. I'm going to call on people one at a time now. So let's start with Skylar. Skylar, I want you to help me with the x-intercepts here, okay? And then after that, let's go to Jaren, help me with the y-intercept, and then we'll go to that point. Okay, so Skylar, how would we get the x-intercepts? What are you thinking?
I want to say set the numerator to 0.
Yep, that's a good idea. And when we have more than one parenthesis, then we're just going to look at the parentheses one at a time. So if I have x plus 1 equals 0, what would make that become 0?
Wait, what was it? X plus 1 equals 0?
Uh-huh.
That'd be -1.
Great. And if we have x minus 1 equals 0?
It would be a positive 1.
Yes, good job. Now, sometimes people are like, well, what about the 2? Well, the 2 doesn't do anything, okay? So the 2 is, as far as the x-intercepts, the 2 is going to play a role in the horizontal asymptotes, but for the x-intercepts, there has to be an x there, in order for us to get an x-intercept, okay? Jaren, what do you think with the y-intercept?
Um,
Do you remember what we said to do on the other example with y-intercept?
yeah, kinda.
What do we do?
You put 0 in for x.
Yeah, and when I do that, that goes away. What's left over?
-2 over -4.
Which that reduces to positive 1/2.
1.
There you go, nice job. So that's all we're doing right there, just like that. All right, someone out there who's feeling confident, how would we get the vertical asymptotes? Just unmute yourself and tell me.
-2 and +2.
There you go, just set the denominator equal to 0, so it'll be the vertical line at x equals -2 and +2. Let's draw that in here. Is anyone feeling confident with the horizontal asymptote? You want to tell me what that is?
Would
Anybody?
it be y equals 0?
Uh,
Or no?
Say that again.
Well, actually, just kidding. Never mind.
Well, Jade, you're already talking, so I'm going to call on you. So our general idea is let's compare the degrees, okay?
Yeah.
So our degrees are both 2. So then what do we do for the horizontal asymptote if the degrees are the same, 2 equals 2?
If they're the same, then it wouldn't it like it would be 2 over 2. So it would just equal 1.
Yeah, 2 over, and right here I don't see anything, that's because it's a 1. So when I do 2 over 1, I get 2. So good job, Jade. That's what we get. So here I'm going to put the horizontal asymptote is, oh, I want to get different thing though, is just y equals 2. Are you guys all following that? For the horizontal asymptote, compare the degrees since they're the same. Look at the leading coefficients. 2 over 1 is 2. So we have a horizontal asymptote at 2. All right, now let's try to figure out what's going on. And again, it's sometimes confusing, but I look at the middle and I say, what shape are we making? And this one, it's a little more obvious. Someone shout out, what shape do you think we're going to see in the middle?
Yeah.
You.
It's the U. Yes, good job. We're going to play connect the dots. And we've got a flipped U. Looks like that. Now, on both of the asymptotes, it's going down, which means over on the other side, it's going to be going up because they're going opposite directions of each other. And there is your graph. I'm going to hurry and graph this on Desmo so I can show you it works. So we have 2x squared minus 2. And we have x squared minus 4. And if someone asked, like, does it matter if you write it when it's factored or not? It doesn't matter as long as you put it in correctly. All right, so here, horizontal asymptote at 2, vertical asymptote at 2 and -2, x-intercept at -1 and 1, y-intercept at 1/2. That looks very similar to what we just came up with right there, except not quite, mine's not quite as nice as Desmond, but it would get full points. All right, any questions on that before we go to our last one? Was there anything on there that was confusing to you? No? If so, please speak up. If not, we're going to move on to the last one for today. Yes. Okay, 30 seconds. Factor that denominator. Go. All right, that was 30. So I'm going to call on Maddie. Can you help me out on this, Maddie? What was your thought process for factoring that?
So I did what can multiply into 8 and add into 2. So I did -8 and -2. And so then what I found out can go into that is -4 and 3.
-4 and what? Sorry, I couldn't hear that last one.
3?
Not.
Or, let me check. Sorry.
You're close. You're close. -4 is right.
4 and 2, right?
There you go. Let's check it. -4 times 2 is -8. -4 plus 2 is -2. So excellent. So when I rewrite this, let's move that up a little bit. When we rewrite this, we're going to get that we've got x plus 2 over, and then I get x minus 4 and x plus 2. All right, thanks, Maddie. All right, now someone unmute yourself and tell me what's going on here. What can we do now?
Can you cross out the x plus 2 since they're the same on the top and
Yes, but there's a big but here. What will that leave?
bottom? Wait, can you say that again? Sorry, my brother came in, so I couldn't hear you.
That's all right. When we cross those out, that's okay. And we're going to just try to figure this out based off of 1 over x minus 4. But there's something we have to remember that's going to show up on our graph with the x plus 2's.
Like, oh, sorry. You can go ahead because I'm not sure what it is.
So if I bring out my notes from last time, guys, remember, if we can cross something out, then it creates a hole at whatever would have turned that factor to be 0. So you could see these from last time, right? So if I have x plus 1's crossed out, then there's a hole at -1. Here the x plus 2's crossed out, so there's a hole at, that should have been -2. Why did I put 2? My notes are wrong. Here the x plus 4 crossed out, so there's a hole at -4. So looking at this one, I crossed out the x plus 2's. So where will the hole be at?
So then the hole will be at -2?
Yes, and I'm going to show you how to find that here. So what we're going to do, guys, is we're just going to focus on this, 1 over x minus 4. Don't worry about anything else. We're going to figure out the x-intercept, y-intercept, vertical asymptote, horizontal asymptote, and just graph it. And if you remember from Friday, this is just going to look like 1 over x shifted over 4, okay? But we're going to now have a hole at -2. Let me show you how to do that. So first off, let's do the x-intercept. I set the numerator equal to 0, and I get 1 equals 0. Doesn't make sense. What does that tell us if you get a false statement, guys? Someone unmute and tell me.
There is no x-intercept.
Good job, thank you. So there's no x-intercept. When I plug in 0, I can cover up the x, and I'm left with 1 over -4, so -1/4. Great. As far as the vertical asymptote, that's what makes the denominator 0, which is 4. So that's our excluded value. So we'll put a horizontal asymptote at x equals 4. And then when I compare the degrees, there's no x's in the numerator, so the degree is 0, and 0 is less than 1. So this is just going to be a horizontal asymptote at y equals 0. So I'm going to just graph this thing. So here's our y equals 0 horizontal asymptote, and then we need to do x equals 4, so I need to come over here to 4. And then what we're going to do is we've got no x-intercept, but we have a y-intercept at -1/4, which is going to be right about here. Now, since that's negative, it tells me on the left, this whole thing is going to be below the x-axis. It's going to look like that. If I'm going down on that side, then this is going to be above like that. All right. Now, what I'm going to do is I'm going to make sure there's a hole at -2. So I'm going to come over here to -2. I'm going to erase just a little bit, and I'm going to put literally an open circle hole like that. And that is what your graph will look like. If you have a hole at -2, then you literally put a hole in your graph at -2. So it looks just like the graph of 1 over x minus 4 with a hole at -2. Now, let's check this on Desmos, okay? So I'm going to go and put it in. It was it x plus 2 over x squared minus 4? Was that right? All right. Now, the problem with Desmos is it doesn't show the hole at -2. This looks just like our graph, right? Except we don't have the hole at -2. Now, if you're bored one day and you just wanted to zoom in and zoom in and zoom in, and you spent like a good maybe 30 seconds here zooming in, what you're going to find is eventually it comes apart, and it almost looks like there's two vertical asymptotes there. But it's showing, oh, there we start to see it's coming apart, and there's the hole, right? Oh, getting closer, getting closer. Oh, it won't go any closer. But there's a hole there. Just trust me, okay? And you can see right there it's starting to break apart because there's a hole there. All right. That's it. That's your lesson. Good job, guys. So now, what I want you to do is I want you to go onto Canvas. And what you're going to do is, for today, there's some practice. What you'll notice about this practice is it's the exact same problems from last time's practice. All you need to do now is you need to graph it. So for this one, you should have already figured out the x and y intercepts, and now you just graph it. Same with the vertical asymptotes, everything else. So if you did your practice last time, you should be able to get this done in the next half hour, because usually we go to 12:04. I'm going to stop right now. Go and do the practice so you've got it down. Now I'm going to do our next lesson on Tuesday. It will be an online lesson, and we're going to talk about, when I give you a graph, how to write the equation. And it's actually easier than you think it's going to be. I'm going to go over that, and then you guys are going to take your quiz. Then we'll have Thanksgiving break. You'll come back, we'll review all 3 sections, and then test on all 3 standards, and then that's it. So please keep up to speed and reach out if you need help. Before you leave, do you have any questions?
No.
No. All right. If you do, you can stick around until less people are here if you're more comfortable that way. But thank you for tuning in. I hope it was helpful. I will see you guys on Tuesday, okay? Have a good weekend. Do something fun, but stay safe.
Bye.
Okay, Berg.
See you guys. And I'm going to pause.